back with me. I'm Octavian Nikia Prento. Today we will talk about computer organization and architecture. For the review question, chapter 5. 5.1. What are the key properties of semiconductor memory? The answer is they exhibit two stable states which can be represented by 0 or 1. They are capable of being written into the state, and they can be read to sense the state. And 5.2. What are two interpretations of the term random access memory? First, a memory in which individual words of memory are directly accessed through wired-in addressing logic. And the second, semiconductor main memory in which it is possible both to read data from the memory and to write new data into the memory easily and rapidly. 5.3. What is the difference between DRAM and SRAM in terms of application? The answer is DRAM is used for main memory and SRAM is used for cache memory, both on and off chip. The next is 5.4. What is the difference between DRAM and SRAM in terms of characteristics such as speed, size, and cost? The answer is DRAM is lower than SRAM, and DRAM tends to be larger and cheaper since it is simpler and smaller than SRAM. The next is 5.5. Explain why one type of RAM is considered to be analog and the other digital. The answer is DRAM is considered analog due to the use of discharging capacitors, while SRAM use a digital flip-flop logical gate configuration. The next is 5.6. What are some applications for ROM? The answer is microprogramming, library subroutines for frequently wanted function, system programs, and function tables. The next is 5.7. What are the differences among EPROM, EEPROM, and flash memory? EPROM is erasable programmable memory. It is read-only but can be erased with ultraviolet light, allowing the memory to then be rewritten. EEPROM is like EPROM but can be erased with an electrical charge. It can also be written into without erasing prior contents, with only the byte or bytes address being updated. Flash memory is the intermediate between EPROM and EEPROM. It is electronically erasable like EEPROM and allows for blocks of memory to be erased, not just the entire chip, though it cannot be erased at the byte level. The next is 5.8. Explain the function of each pin in figure 5.4b. This one is figure 5.b as you can see, and the answer is for A0 until A1 is A0 until A10 is address line, CAS is column address sag, and D1 until D4 is data lines, and NC is no connect, OE is output enable, RAS is row address select, VCC is voltage source, VSS is ground, and WE is write enable. The next is 5.9. What is a parity bit? A parity bit is a bit in a memory compartment used on 4-bit words that is used to determine the parity of the 3 remaining bits, 1 or 0. 5.10. How is the syndrome for the Hamming code interpreted? If the syndrome contains all zeros, so that means no error has been detected. If the syndrome contains one and only one bit set to 1, then an error has occurred in one of the 4 checked bits, and no correction is necessary. If the syndrome contains more than one bit set to 1, then the Numerical value of the syndrome indicates the position of the data bit in error. That bit is inverted for correction. Next is 5.11. How does SDRAM differ from ordinary DRAM? SDRAM is synchronized to an external clock signal and running at the full speed of the processor or memory bus without imposing wait states, while DRAM is asynchronous. The next is 5.12. What is DDRAM? DDRAM stands for Double Data Rate Synchronous Dynamic Random Access Memory. These are the computer memory that transfers the data twice as fast as regular chips like SDRAM chips because DDR memory can send and receive signal twice per clock cycle as comparisons. They are widely used in applications that are demanding high-speed memory, for example graphic cards that need to access a large amount of information in a very short time to achieve the best graphic processing efficiency. 5.13. What is the difference between NAND and NOR flash memory? The answer is NOR and NAND flash memory are different by their architecture and purpose. NOR memory is used for storing code and execution, allows quick random access to any location in memory array. NAND memory is used for data storage. The last one is 5.14. List briefly define three newer non-volatile solid-state memory technologies. First, Intel obtained DC persistent memory, which is non-volatile, high-capacity memory tuned for data center workloads, can be accessed through memory operation or as block storage. The second one is MRAM, non-volatile memory that can be powered down completely, then overcome quickly for fast writes in an IoT application. And the last one is RAM, promised to bridge the gap between DRAM and flash in the data center. Storing entire database in fast, non-volatile RAM would revolutionize in memory computing. That's all from me today. Thank you for watching. Hope you like it.